Welcome to the second video in a series of 3 looking at how to use Excel as a tool in an engineering environment. So, in the last video we looked at cell referencing, the basics, and how to use formulas. In this video we want to take this a little bit further. So first thing we're going to look at is how you can change the number of decimal places your figures are shown to within each cell. There are 2 ways of doing it. So for example, if we're looking at this 0.5, which is the value of our area here, and we wanted to change the number of decimal places it's shown to, the easiest way to do this is in our number section up here. So if we press this button here, we're increasing the number of decimal places that our values are shown to. If we press this on here, it's decreasing the number of decimal places our value will be shown to. So for example, if we want to put everything to 2 decimal places, we can just click that once, and that's what's at there. Another way we could do this is we could highlight everything that we, for example, if we wanted this to happen for all cells, we could highlight everything that we wanted to change this for, or we could do Control and A to highlight everything, and we could right click, format cells, and then on the window that comes up, you can click number and choose the number of decimal places. For example, I'm going to change it to 3 here, and then everything here is now shown to 3 decimal places. And this means if I start adding a value in here, for example, 6.893, this will come as 6.893 here. And then if I wanted to do this to another decimal place and add that there, it will round that to the 3 decimal places. So this is how we're going to change the number of decimal places our values are shown to within our Excel spreadsheet. So what we've got here is a set of example data looking at the velocity of water through a pipe. So it's not always the case of when we're doing some experimental analysis that we just want to know the velocity in meters per second, or we might not be able to measure the velocity in meters per second. So therefore, it is important that we are able to change our value from a velocity to a volumetric flow rate and also to a mass flow rate, as you could be given any one of these 3 and need to transfer it to any of the others. So this is what we're going to look at here. So down the side, we've got 3 repeats at each velocity that we've been able to set. So our velocity here is our independent variable, as this is the one we are manipulating. And here we have some blank columns for the volumetric flow rate and the mass flow rate. So first things first, we might want to make our table look a little bit nicer. So to do that, we could highlight everything and then go up to the border section in font and click all borders. This might make it a little bit easier on the eyes to be able to see what goes with what. And when you're working with data, it is always good to make it as presentable as possible. So if someone else needs to look at your data, they are easily able to interpret it. So another issue we have here is the presentation of the Excel spreadsheet. Is if we scroll down, there is so much data that we lose the top of the table where all of the titles are. So to avoid this, we can use a function called freeze panes. So we want to select what would be the top left-hand corner of the bits that are going to start moving. So as we want to keep the experiment number, the velocity, and all of these column titles stationary and frozen in place, we need to go to the row just below it. So to freeze our panes, we want to go to the View tab up the top, then come over here to Window, and you'll see a button called Freeze Panes. Click here, and as you can see, you have options to freeze either the top row or just the first column. Whereas here we've got a little 6 rows that we'd like to freeze. So therefore, if we click Freeze Panes here, you can see the line across where that's going to get frozen and then down that column. So if I scroll along, that column A will stay frozen. And if I scroll down, you can see the top 6 rows stay frozen, and we can still then see the title and the units that are going to be shown at the top of the table. This can be very helpful, especially when you go down into hundreds of rows if you're operating with a large data set. You can change where you want to freeze, so you could just freeze the top 6 columns and no rows, and none of the columns. So if we just unfreeze there and highlight the cell A7 and then go freeze panes, you can see that none of the columns are frozen, but we still have those top 6 rows frozen into place. So this will help when you're trying to do some data analysis to stop you getting as confused. So now if we start looking at doing the actual calculations we need to do. So how is the volumetric flow rate and the velocity related? Well, as you can see here, in this cell that I've just highlighted, the volumetric flow rate Q is equal to the velocity times the cross-sectional area A. So that is Q equals UA. Okay, so we've got our cross-sectional area of the pipe, we know to be 0.5 meters squared, and we've got our recorded velocities here. So what we want to do is, for the volumetric flow rate, we want to multiply the velocity by the cross-sectional area. So to start that, we type in the equals to start our formula in the cell, then we select the velocity, and then we want to multiply this by the area. Our volumetric flow rate is 2.4 meters cubed per second. Okay, so we want to repeat this for all of the data sets, but as you can see, if I just drag down the formula here, and dragging down a formula is a way that we can copy the formula down in a column or across in a row without having to type it in every single time. So we could drag that down. As you can see, we've got an issue here, as we know that the 5.5 multiplied by the 0.5 is not 0, so something has gone wrong. And this is because, as I drag down my formula, it drags down from the reference point. So this cell, if we look at what it's actually doing, it's multiplying the 5.5 with the cell below the 0.5. This is because it's taking the next row down from our initial formula. We don't want this. We want the area to stay on that cell for each one of these rows. So to do that, we need to do something called absolute cell referencing. This allows us to then keep, even when we drag down our formula, to ensure that we're still referencing this column and this row that's G4. Okay, so to do that, when we get to the G4 in our initial formula, we want to put a dollar sign in front of the letter and then another dollar sign in front of the number. So if we try this again, so we just go to the way to drag down a formula to copy it down into the other cells. This goes to the bottom right hand corner, and as you can see on my cursor here, you go from a large white cross like that to a thinner black cross like this one. So when it's the thinner black cross, you just click and then scroll down, and you can see that if I go down all the way to the bottom here, we now have calculated our volumetric flow rate for each of the velocities on the side here. Okay, so that's nice and simple. It's crucial though that we remember to do that absolute cell referencing. As you can see, we're staying on G4. If you look up the top here, through each one of these calculations, we're still referencing the G4. So we can do something similar here with the mass flow rate. We can only calculate the mass flow rate through this on the assumption that our temperature is staying the same, so therefore our density is staying the same. So as we can see here, our density is the mass over the volume. So therefore, to get the mass flow rate, we're going to want to multiply our volumetric flow rate by the density. So we can do something similar to what we've done before here. So equals to start off our formula, and then we're going to want to highlight our density, and then we want to multiply that by the volumetric flow rate. Again, we want to do some absolute cell referencing on the density value, as this is going to be the same for each one of our calculations. So you're going to put a dollar in front of the C and then another dollar symbol in front of the 4. So if we click enter here, we've got our mass flow rate, which is 2,400 kilograms per second, and then drag all the way down to the bottom, and we've got all this worked out. So this is much simpler and easier, being able to drag down the formula instead of having to repeat each one of the formulas for each row. Then finally, what we can look at in this video is sorting this data. So, for example, for each of these, you might want to have them organized from lowest to highest in the velocity. So to do that, we're going to select all of our velocities here. We're going to come up to our editing part of the Home tab, where there's the sort and filter button. I'm going to click here. There's multiple options. You can create some custom sorts and you can do some filters. So this is a little bit more advanced than what we're looking at right now. But for example, for a filter, you could choose to pick out any experiment of number 2, for example, and then it will just show you the second runs of each of the experiments. Or you can do some custom sorts if you're looking at multi-columns or rows or anything along those lines. Just here, we're going to look at the basics of organizing from smallest to largest. So we're going to do that, and then we're going to have a window that pops up and asks it says Microsoft Excel found data next to your selection. Since you've not selected this data, it will not be sorted. what does it want us to do? We want to expand the selection, so this means that everything will stay in order with us, so the experiment number and all of the calculations will stay in order, so we're only changing the order of everything, but the rows are still aligned. So we click sort, and then we go through here, so you can see our experiment numbers are now in a bit of a random order, but our velocities will increase from the smallest to the largest all the way through, and therefore our volumetric flow rate and mass flow rate will also do the same. So that is how you sort on Microsoft Excel. So in this video, we've looked at how to start doing some basic data analysis, how to drag down a formula, absolute cell referencing, as well as increasing the presentation of your data with freezing panes and doing some outlines on your table. So I hope this has been useful, and in our next video, we are going to look at how to create graphs and charts in Excel.